Hello everyone and welcome back to another edition of Indexer Office Hours. Today is the 22nd of October and this is Indexer Office Hours 180. We're almost at the 200 mark. I believe the 𝗨𝗀𝗃𝗀𝗀 episode is closer to the 200 mark, but we're slowly edging up, and that's great to see. If anyone is new to Indexer Office Hours and just peeking at the chat now, we do have a few new faces. This is the town square where graph ecosystem participants come together and discuss the most important and relevant topics for indexers. This is a conversation, as always, and we love participation. A few folks like to hear that when I say that, and I very much do mean that. This is a conversation, especially today's conversation. It's going to be all about Kubernetes. So yeah, get involved in today's conversation. You can do that via the chat box, which many of you are already utilizing, or by unmuting your mic. And of course, if you're having any challenges there, let me know. Yes, we should have. I should record that and then put it on the soundboard. That would be pretty fun. I'll see if I can message Payne to sort that out. That would be pretty fun, actually. So yeah, feel free to unmute your mic and I can help you out there if you're having any challenges. And just as a reminder, but do it in a French accent. Oh gosh. Oh no, I'm happy to, but that would be very embarrassing. I feel like I would maybe offend a few people with how bad it is, but yeah, that would be pretty funny. So yeah, if as a reminder, this is a call that is recorded and posted onto public channels like YouTube. So if you are concerned about privacy or maybe embarrassing yourself like me, please bear that in mind. I love the chat. The chat is on fire today. Would you like a you need a bottle of water? Indeed, I'd like a bottle of water, please. Yeah, as I said, today's an exciting agenda, so let's get straight into it. So as always, we shout out the latest 𝗨𝗀𝗃𝗀𝗀 episode, and today is no different. And we are looking at episode 191 with Ben Hugh, if I'm pronouncing that correctly, H-U-H. Yeah, perfect. Juan's already posted that. And he is a entrepreneur and and an investor as well. He's spent a lot of time in the Web3 space looking at DAOs, data, that kind of stuff. Studied at Northwestern and has some interesting views on Web3. So if you're interested to learn a bit about his background and his story, then do go check out the episode there. Wonderful. It is Tuesday. It is Tuesday. I love that. And without further ado, I'm going to hand over to Anna for our regularly scheduled Repo Watch section.
Thank you, 𝗨𝗀𝗃𝗀𝗀, and hello everyone. Today on Repo Watch, starting as always with execution layer clients, we have had a new release from Firehose Ethereum. This is version 2.7.5. This is a substreams fix, so it fixes data corruption in some store policy operation, which requires cache deletion. And this release also improves the development mode request startup times. Then we also have a new Nethermind release, version 1.21.1, which is a mandatory validator upgrade that addresses some Linux memory regressions. It includes a OP stack, sync performance issues, and a Gnosis chain block production edge case. We also have an Avalanche new release, so version 1.11.12, which is an optional but strongly encouraged update and includes a lot of improvements, including OP stack sync optimizations, enhanced P2P handling, plus others. Then moving on to consensus layer clients, here we have had two new releases from Prism. So the least recent one is version 5.1.1, which is a recommended update that turns on experimental state management by default. And it also includes improved bandwidth stability for libp2p updates. Worth knowing that this release deprecates gRPC gateway in favor of Beacon API. So make sure you're careful with updating this. And then the most recent release here, so version 5.1.2, which is a fix on top of the previous one. So fixes panic recovery in Beacon API streaming events. So those are the two for Prism. Then we have a new release from 𝗨𝘀𝗃𝗀, so version 24.10.2, which is a hotfix to address an issue affecting Windows users only. And then we don't have anything new. Oh, sorry, we do have on GraphStack, we have new releases from indexer tab agent. So release version 1.2.0, which improves error handling with backoff moved to tracker, enhances performance for concurrent RAV requests, and optimizes fee calculation using latest RAV. So this is an important release. Then we also have another release also for indexer tab agent, so version 1.2.1, which includes a bug fix for the default levels for logs. And this is all we have. Matthew is letting us know that they have a firehose upgrade in progress at Pinax. And on our side, we haven't yet tested any of the new releases for this week, but we will soon. Okay, over to you, Juan.
Thanks, Anna. So starting with Protocol Watch, first of all, form governance, we have a new chain that requested integration. This is Chili's chain, which I think it's a fork of BSC. Again, if you're interested in the details on how to run it, they should be in the thread that's linked in the agenda. I think it's a fork of BSC from what I could read. I glanced at the thread though. Yeah. So next up, for form research, we don't have new updates since /h. Last time we covered the core dev updates. For the contracts repository, there are a few PRs outstanding, mainly dependency bump from one of the packages, which seems to be a crypto package for encryption. Then, fixing a few missing parameters to the deploy script, and some Horizon PRs that have been closed. For the network subgroups, we don't have new updates in /h, and that's pretty much it for Protocol Watch, so it was a short one. Yep. So I'm going to hand over to Abel now.
Yes, that's right. So no packers, so straight back to me. So if you guys remember the last time we discussed Kubernetes, we unfortunately had a very packed agenda and couldn't get to all of the goodies. So we have the good fortune of inviting the Pinax folks back onto the call today to basically go over some of the things in more detail, of course, answer all questions, and just kind of do it in a relaxed fashion, because I think it's fantastic content that needs time to do it justice. So yeah, without further ado, Guillaume, feel free to grab the mic and take it away.
Yeah, all right. Also share my screen. Okay, hopefully you guys should be able to see what I'm sharing.
Yes, sir. Yeah, it now.
Great.
You're in a camera, right? Yeah.
Okay, so I don't really know where to take this. I'm gonna try to present sort of the same thing I did last week, just a bit slower. Hopefully you guys had the time to look at the repo and play around and kind of poke the bear a little bit to see if you have questions. So please, if there's any question, ask away. Ask in the chat. You can interrupt me. You can unmute your mic, whatever. It's all good. So this demo was meant, like I said last week, as sort of a startup point to play around with Kubernetes in a simple way and to try it out, because obviously the whole ecosystem is now moving towards Kubernetes. So having this deployed instead of a bunch of Docker Compose files or stuff like that is just way more scalable. So this was meant more as a kickstart or a launch point, if you will. So this is the same repo as last time. I didn't make any change to this. So basically, this Kubernetes setup is using Kind. I glanced over Kind really fast last week. Basically, Kind, I can open a browser here and go on the docs. Okay, so Kind is this tool here. I can also share the link in the chat. Oh, no. Wow. Okay, thank you. So
Already
quick.
done it, yeah.
Yeah. Okay, so yeah, Kind here is a tool that we use in the demo. It's not production grade, obviously, but it's really great for developing and trying stuff out and wanting to deploy a Kubernetes cluster the simplest way possible. So basically what it does is the only thing you need to have is Docker installed on your machine. And then it's going to create the control plane, the worker nodes, every Kubernetes component in a Docker container itself. And you can create multiple nodes by setting up multiple Docker containers, and then you can replicate the whole cluster in your local environment. And you can do a bunch of things with that. You can do external load balancing from your Kind cluster. You can do ingress from your cluster. I've also set up some sort of DNS to do local DNS from a Kubernetes cluster. So if you want to test, like one thing we did at Pnax was set up our own DNS provider for services. And so I was able to use Kind to bootstrap a DNS infrastructure inside of Kind and then use this to test for services. And then we can deploy this to production. So there's a bunch of stuff you can do with Kind here. And setting up a cluster is really easy. Basically, right now everything is deployed from a tilt file. So this is just, you can think of it as a make file, but specifically aimed at Kubernetes. So this way you could have, if you have an application you want to code and you want to have live updates inside of a cluster, you can use a tilt file to reload and recompile your app and update your Kind cluster automatically. So it's just like a make file with extra steps, basically. And the Kind cluster, I think it's in script. Yeah, okay. The Kind cluster config looks like this. So it's basically just a YAML file, and you get to set up a bunch of things. So right now I have a control plane with Kubernetes version 1.30.4. You can set up mount path. So if you want to have data or stateful application in your Kubernetes cluster, then you can give it a container path and set it up like this. Port mapping, so networking. You can have so this is really simple. And to basically the script, I think, yeah, basically that's the only thing I do. I just get this file and I say Kind create cluster, and this is my config. And so it's all there is to it. Creating a cluster with Kind is really easy. There's also multiple tools you can use. There's Minikube, that's really popular too. I just find that Kind is a bit easier and faster in my experience, but your mileage may vary. So I can create the cluster. I'm gonna do make nuke just to be sure, and yeah, make setup. So this is going to create the cluster. And as I said, Kind is basically a whole Kubernetes cluster inside Docker containers, and it's going to deploy a bunch of tools for your cluster. So if you look at what's going on in the cluster, you can see that the Kind control plane is going to deploy a netcd inside of Docker. It's going to deploy a controller manager. It's going to deploy a kube scheduler, the API server, and usually it would also deploy the internal DNS. So usually Kind, I think it uses Flannel to do the CNI. So the CNI is your container networking interface. Basically, it's the tool that is able to link pods and containers inside of your cluster together. So if one pod wants to send a request or whatever to another pod running in the cluster, they need to be able to communicate with each other. Usually you use some sort of cube DNS, and so we call it cube DNS, but that's an old name. Nowadays it's core DNS, but it's still called cube DNS just for compatibility's sake. But basically, this is the tool here that allows your pods to communicate with each other. And well, right now it's not going to be deployed because if you look at the configuration, I specifically requested to disable the CNI. So there's no networking interface in the cluster because I don't want to use Flannel. I want to use Cilium because this demo was part of a cluster mesh demo. So I'm just going to do make up, and this will deploy a bunch of stuff. If you look at the browser, you're going to see this is all what's deployed from the tilt file. So there's the tilt file itself, then Cilium Envoy, the Cilium operator. While we're waiting for Cilium, there's some load balancers, CRDs that we want to deploy, and then there's Flux and some uncategorized stuff. So a bunch of CRDs are going to be in there, a bunch of stuff deployed automatically. And if we go back here, and I'll probably create a... Let's look at the cluster. Okay, so now that the tilt file is up, it's gonna deploy Cilium while it's ready, blah, blah, blah. So everything's ready. Down the LBCRDs are deployed, and now Flux is gonna be reconciled, and Flux is gonna be used to deploy a bunch of stuff in the cluster. So in this demo, we use Flux for not the CI, but for the CD in the cluster, so for the continuous deployment. There's a bunch of tools here again that you can use. There's also Argo, there's Flux, there's another one I forget, but mainly Flux and Argo are the two main tools in the space. And now everything should be deployed. Yeah, so 8 out of 8, and we can look at the tilt file. We can see the log of everything here that's deployed. So Flux looks like all components are healthy, so everything should be deployed in the cluster. So let's have a look at it. Yeah, there you go. So basically, there's a bunch of stuff that happened right there. But the kind cluster deploys everything you saw earlier. So the cube controller manager, the API server, the scheduler, the etcd control plane. So this way we can store what's happening in the cluster. And then it waits for the CNI and the local storage provisioner, because the local path provisioner needs the CNI in order to be able to provision storage on your machine. So with the tilt file, we deployed Cilium. So Cilium is using Cilium Envoy, Cilium, the operator. So this, when it's deployed, then core DNS will work and the local path provisioner will work too. So from there, you have a fully operatable Kubernetes cluster. And then we deployed...
Why you want to choose Cilium? Why is that important?
Oh, yeah. It's a good question, honestly. For this demo specifically, I chose Cilium just because Cilium can do cluster mesh. So this is a way to have services between clusters across data centers. So this is something that we need at PNAX. So we have multiple data centers and we want services to be accessible from one cluster to another without using some sort of WireGuard tunnel or stuff like that. That's really... It's really slow, really, because the latency is quite killer in these scenarios. So using a WireGuard tunnel is very hard on latency. And so using Cilium, it doesn't use WireGuard and stuff like that. It uses ePBF at the core. So it's hooks directly into the Linux kernel, and you can parse and you can inject code directly in the kernel to reroute your packets across data centers, and it's much faster and much more flexible than just a tunnel. So that's why we used Cilium in this demo. I think at this point in Kubernetes world, Cilium is like the gold standard, or it's like the gold standard of Kubernetes and CNI. So pretty much every cloud provider is moving towards Cilium. So yeah, that's it. When in doubt, you can just use this. Isn't cluster mesh established with tunnels between cluster? Not sure. I'd have to look. It's been a while since I've played with cluster mesh. Maybe it is. I know there's a bunch of stuff that they do for the cluster mesh, but yeah. Okay, so yeah, that's why we use Cilium. Other than that, there's also Flux that was deployed. So we have a namespace here, Flux system. So Flux deployed a bunch of controllers. So there's the Elm controller, the image automation to give you automatic update, the image reflector, which is also part of the image automation update controller. So these two really work with each other. Then you have the customized controller, which is your controller to be able to create deployments from customizations. You have the notification controller. So this is the thing that says, oh, when there's an update, send me an update on Discord, send me an update on Slack, send me stuff wherever. And you can have webhooks with the notification controller. So this way you can track and have alerts for every deployment, or if there's a new version of an app, you can have a notification. And then there's the source controller. So this is just the controller that pulls GitHub repos or Helm repos or any container image repository or whatever that your applications are going to use, or even where your applications is stored. So this is just for like source file and repository and stuff like that. So this is the Flux part of this deployment, and we chose Flux at first at Phoenix because it was just easy, right? From an operator's point of view, Flux was just very easy and very straightforward to bootstrap and play around with and extend, because it's made to be very simple and unopinionated. So it does really one thing and only one thing, and it's the CD, and it's pretty simple, but pretty easily extendable too. So you can use Flux to do multiple clusters with multi-tenancy and stuff, and be a very straightforward and easy solution that you can extend with different tools. There's also Argo that does stuff similarly to Flux, just in a more opinionated way with an all-in-one toolkit, rather than having you being able to extend and use different solutions for different parts of the whole cluster. And Argo, really the main advantage that Argo has from a user's point of view, I would say, is the UI. The UI with Flux is just the kubectl commands and tools you can use. But if you use Argo, then you get a really nice UI for your application. So people usually gravitate towards Argo for the UI. And usually when people do infrastructure, they tend to gravitate more towards Flux. So you can also mix and match both together, right? So you can do, oh, if I want to have 500 clusters to reconcile, I can use Flux for the infrastructure and then manage my applications and my tenants from Argo. You can use both. You can use either or, right? So that's Flux in the cluster. So right now, pretty much everything is deployed. If we look at the, if you have questions, please ask away in the chat. Okay, so let's look at the GitHub repo. Why am I not signed in? Okay, I'll just... oh, wait. I'll move this in the screen. There we go. Okay, so 2FA, that's great. Okay. So it should be here. Okay. So from a user or developer's point of view, this repo here is used to reconcile the cluster and the application running in the cluster. And so this is used by Flux to reconcile basically everything that's running in the cluster aside from the CNI, which is Cilium again. So the way this repo is structured, I can zoom in a little bit. But basically, there's the clusters directory. So here I just have a single cluster, which is 𝗨𝗂𝗲𝗂𝗧. But if we look at, let's go and get, oh no, let's just open a new thing here and look at something we do at PNAC, so the fleet. So we have in clusters, we have a bunch of clusters that you can deploy from there. And so this single repo can manage multiple clusters from a single point. So right now we only have this cluster is in the 𝗨𝗂𝗲𝗂𝗧 demo, and basically there's the Flux system. So this is the Flux customization that you use for every controller. So we have the customization controller, the source controller, the Helm controller, the notification, and blah, blah, blah. So everything you want to use goes in here, right? And every patch you want to apply goes in the customization.yaml file. So right now there's not much because obviously it's just a bare bone customization. But if we take a look at, let's say the MarDev1 cluster at PNAX, you can look at the customization. And this is where we can put per cluster and Flux specific options for your deployment. So right now we have the concurrent limit for the Helm controller and the source controller. So we say that we want to be able to reconcile 20 concurrent deployments at the same time from the Helm controller or the source controller. We have 40 concurrent customized controller because most of what we do is with customizations, so it just made sense to have more concurrent customizations there. You can scale vertically or horizontally your components, so we give more RAMs and more RAM, more CPU. You can have in-memory building, so because pulling stuff from GitHub takes some space on disk and we want to do concurrent builds, it just made more sense to load everything from Helm repos into RAM and build from RAM instead. So this way we can avoid just having stuff on disk and modifying and being IO bound really. So there's a bunch of things we do here to make build time and deployment faster. So this is where you do it from your customization.yaml. And then you have, if we go back a folder, you have Flux system, and we have a bunch of YAML files here that are going to be Flux customization. So these are infrastructure, I'd say, infrastructure customization that are going to manage a bunch of stuff. So we have the automation customization. We have the cert manager. So cert manager is the tool we use to have TLS certification generated automatically for our routes and endpoints at PNAX. Then we have the Launchpad chart. So this is really just our application customization, right? So there's only one app in apps, and it's the Launchpad graph node, and well, there's a DB also, but yeah, there's mainly one app because this single thing is deploying both the DB and the Launchpad charts. There's the monitoring. So for monitoring, we're using Prometheus, so everything is deployed from there. And then you get your Postgres controller that is deployed in infra. So this is all that's deployed from your cluster. And then you can, in this repo right now, we have the apps, the infra, script secrets, and an update is for the automation controller. So you have your automation script here that basically you create some policies and image repository. So you create this image repository here, you give it an address, you give it an interval. So you're saying just parse this repo once per hour, and the provider is generic. So it's just a normal GHCR or really OCI container repository. And then you give it an image policy. So you're saying, please keep and prioritize tags that are semver over 55.0.0. So once per hour, this Flux, the automation controller, will send a request to this address and parse tags, and not parse, but really pulls all the tags, and it's just going to keep the tags that match this policy, and then it's going to select the tags that best fit this policy. So right now we want everything over 55.0.0, so it's going to presumably pick the latest tag. I don't know what it is right now, it's 60 something. So it's going to pick the latest one and compare to in infra, in monitoring controller, it's probably here. Yeah. In infra, we have this annotation here, which is image policy, flux system, 𝗨𝗀𝗃𝗀𝗃 stack tag. So it's gonna grab the latest tag from the image policy and it's gonna replace it automatically here if it doesn't match. So let's say, for example, there was a new version of Prometheus that was published in the container registry. Then at the end of an hour, Flux will pull this repo. It will see that there's a new version, so 65.3.3, let's say. And so it's going to automatically update this from a commit. And the commit can be configured in this automation.yaml. So this is an image update automation. Basically, you create your template for your commit message. So right now it's just like, I can probably, I don't think there's a commit in here. There's 2 commits. Automated image update. Oh yeah, there you go. There's one. Okay. So the automation name, so it's from Flux Infra, the file that was changed. So monitoring, blah, blah. Okay, yeah. So it was the last time we did the demo, it was 65.2.0. So when we bootstrap the cluster, it pulled tags from the Prometheus stack and it noticed, oh yeah, we're now at 65.3.2. So it automatically detected the new tag. It changed this line in the file and this file was reconciled. So if you look at the cluster and we go look at the kube Prometheus stack, which is right here, you can see that the version that's running is the new version. Right here, it's 65.3.2. So it automatically updated the cluster. I didn't have to do anything. So this, you can imagine, you can use for new versions of all types of application in your cluster, right? So if you want to have updates for blockchains or endpoints or what have you, you can use this to automate the whole process of updating and keeping chains updated in real time. So yeah, that's the automation part of this deployment. Then you also have, let's go back a bit. Yeah, okay, so in infra, we have the monitoring that I'm not going to talk about, but it's using Postgres, it's using Prometheus. Then you have the database with Postgres, so we can deploy Postgres databases from Kubernetes itself. And then we have Cert Manager that I already mentioned, so to have TLS certificates. So this is all the infrastructure that's running in the cluster. And then you can deploy your apps from a similar pipeline using Flux too. So basically, if you go in let's go in the clusters, IOH, and where is it? It's Launchpad charts here. So basically, this is a customization. So it's just manipulating raw Kubernetes YAML manifests from customizations. And it's saying, okay, this application, you can see a customization as like a full-fledged application. So this application depends on the monitoring, Cert Manager, and Postgres, because it's going to use all 3 of those. I want you to go and pull from the repo that's hosting these files every 5 minutes. And if it fails, if you don't have a success after 4 minutes, then it's going to fail, and retry the deployment after 30 seconds after a failed state. You have prune and wait. So prune, what prune means is if you delete this customization from your repo, please also delete every resources that were deployed as part of this customization. So this customization is going to deploy presumably a deployment, a namespace, some PVCs to hook storage to. It's going to deploy some Helm releases. It's going to deploy a bunch of stuff. So what prune means is if I delete this customization from my repo, so let's say I delete this file from the repo, Flux is going to reconcile the repo. It's going to notice that this file doesn't exist anymore. So it's going to automatically delete this customization. And since we have prune to true, then it will also delete every object that was created from this customization. We also have wait to true. So what wait is basically set this customization to a ready state once every resource is successfully deployed and ready in the cluster. So if you say wait false, it's going to just try to deploy the files and then say, all right, I'm ready, I've done my job. Even though there might be some mistakes or some errors in your configuration, the customization will still be ready. But if you do wait true, then it will wait for every resources to be ready. And then if you have an error, then the customization won't be ready, obviously, because some resources won't be ready either. Then you have the source ref. So the source reference is where to actually get the files from. So we get it from a Git repository, and the name of this Git repository is Flux System. So right now we're just using a single repo to update the infrastructure, the application, everything in the cluster. So this Flux System repo is created at cluster bootstrap time. So if you look at the Flux System and 𝗨𝗂𝗂𝗧𝗂 component, oh no, I think it's sync, right? Yeah, 𝗨𝗂𝗂𝗧𝗂𝗧 sync. So you're going to see that this Git repository is created here from Flux itself. So we're just reusing this Git repo because obviously our application deployments and files are located in the same repo that the Flux bootstrap repo is. So we reuse the same, but if you have more than one clusters or tenants or multiple applications running in your cluster, then presumably you'd want to have one repo per application or per tenant, or if you have, I don't know, 10 clusters, you might want to have a repo per cluster, or you might want to have a repo only for infrastructure for your clusters, and then have a repo for your application, so you can mix and match. And so right now I'm just using this repo here, but as you can probably imagine, you can have a bunch of repos for many applications. And yeah, that's mostly what this oh, and then there's the path, right? So the path is at the root of this repo that we're going to pull from. So the path that we want to deploy from is the apps path. So it's going to go and grab this repo, which is the repo where we're located, and then look into the apps directory. And so from this directory, it's going to look for either a customization.yaml file, or I think it looks for a Flux customization itself. But it's going to go in apps, and it's going to go and grab this customization.yaml file. So it's going to stop there, and it's going to take everything that's deployed and everything that's mentioned here and deploy it. So right now it's doing, oh yeah, deploy the graphnode.yaml and graphdb.yaml. So these two files. And these two files are Flux customization. So deploy the DB. So it works similarly to what we were doing before. So we're just, instead of deploying the whole apps directory, we're just deploying apps/db, and graphnode, well, we're going to be deploying apps, launchpad, and graphnode. So we're going to deploy the graphnode, and this customization depends on the graph database, obviously, because we need a database to do the graphnode. And so all of this will be automatically handled by Flux when you bootstrap your cluster and reconcile your repository. So you don't have to always manage these sorts of things. Flux will do this for you. So that's basically the whole cluster stack. I think I said pretty much everything that's running in the cluster and how it works. I can talk about Helm. So there's something I didn't mention. So I talked about graphnode and customization, but basically you can also use Helm charts, and that's what we're using in this demo to deploy the graphnode. And you can use this as part of Flux. So if you look at the graphnode customization, well, it's going to try to deploy everything that's running in this directory. So apps, launchpad, graphnode. It's going to go grab this customization and create the namespace graphnode if it doesn't already exist, and then deploy this file here, which is the graphnode YAML. And basically this is a Helm repository. So this Helm repository that we name GraphOps, and we're going to pull from the repo every 12 hours, and we give it the link to the repo. So GraphOps, GitHub IO, Launchpad charts. So it's going to grab every chart from this repo every 12 hours. And just so we're keeping updated with every version of charts and stuff. And then we're saying, okay, create a Helm release. So a Helm release is just actually deploying the Helm chart in an application in your cluster. And what we're doing right now is deploying an Helm release called Graph Node. So the chart we want to use is Graph Node, the version of the chart we want to actually deploy, the source reference for the chart. So we want to use the Helm repository GraphOps that we created earlier. And then the interval, so the interval for the chart. So we're gonna see, and if the chart doesn't have change every 12 hours, then there's some kind of flux stuff. So the install upgrade policy. So when we install the chart, we want to create the CRDs, and we want to do this in timeout in 9 minutes. So if it doesn't work after 9 minutes, just fail and send me a notification. And then the upgrade. So if we upgrade the chart, so let's say we'd want to go from 053 to 054, then create and replace. So if the CRDs don't already exist, create them, and if they do, just replace them with the new versions of CRD. So if there was some CRDs that were changed when changing version, then obviously just replace them. And then there's the values part. So here it's just the values that YAML file that's part of your Helm deployment. So there's a bunch of configuration here for the application. Something that's really nice to do too with Flux, I didn't do it in this demo, but if you look at what repo is this? Okay, so this is the fleet. Let's go back a bit and go in the infra. And let's look at, I don't know, some networking here. Okay. So this is a great example. So this is another Helm repository and Helm release that we use for DNS in the cluster. But basically, instead of giving it a values file, not a values file, but a values node in the YAML and then putting all your configuration, we basically just link a config map instead. And the config map is created as part of this root customization for the application. So basically, we use a config map generator, so the Flux Kubernetes Gateway config, and we link it to a file, which is here, so the Kubernetes Gateway config file. So this file is just the configuration for your application. And you can see this as being like, this doesn't change much, or what's the point of this? It just seems more complicated. But what's really great about doing it this way is basically you're gonna always automatically regenerate a config map if you change your application setting. And so the Helm release itself will be automatically redeployed and updated if you change any setting in your values.yaml file. So you don't have to use a tool like, I forget what it's called. I think it's not Renovate. It's I don't know, but there's a tool that Reloader, I think it's called. I don't remember, but there's a tool in Kubernetes that does basically this for you. But you don't have to use a tool like this if you use this sort of config map generator with Flux and stuff like that. So that's how to use Flux with Helm releases, because most of what you're going to end up deploying are probably going to be Helm releases at the end of the day. But you can do customization, you can do a bunch of stuff with this. So I think that covers pretty much everything on the deployment. Again, the repo is available public, and it's 2 commands away from you being able to play around with the graph node and play around with the cluster and deploy it on your own laptop or infrastructure or whatever. Yeah, thank you, Gabriel. It was Reloader. Yeah, okay, I'm not crazy. So that's pretty much it. Any questions on the whole cluster or the whole demo, really?
Fantastic. Now is your time, folks, to ask your questions. I mean, just monitoring the chat while you were demoing there, people seem to have been like conversing and then asking questions, and it's been like a nice back and forth with several people. So I'm assuming a lot of questions have been answered. But let's keep going. If people have questions, like fire away. This is a great opportunity to get them answered.
I'm hoping, even if you don't agree with all of the configuration that we have in Pinax, we change our minds sometimes too. But at least, maybe it gives you some other ideas or, questions to ask or things to think about. So I'd love to hear also more what other teams or people are doing around Kubernetes. So great way to share between the different indexers.
Indeed, indeed. Alpha sharing is always welcomed. I see a few people typing, so we'll let that run. There's a question there from Vince to the group.
Please tell me if you're using GitOps. No, we do everything manually, right? Isn't that the right way? Kidding. Yeah, that's right. SSH is all you need. Forget this Kubernetes stuff. Forget Helm charts. Forget anything. Just SSH and run commands. And if you want to know what was done, look at the history. Yeah. Ooh. Great to hear, Marc Andre. Always happy to, feel free to follow up with questions. Just reach out and ask the team if you have questions about anything that was demoed.
Yes, yes. And John seems to have questions, not specifically about K8, but tap agents. Feel free to ask them because there are many folks in here who are familiar. So I see Anna's unmuting, so yeah, go
Mhm.
ahead.
John, you don't need to add that aggregate that gateway. It's just an additional gateway that's running that someone set up. So right now, the only officially supported gateway is the Edge and Node one. But the tap agent will show that for any gateway that exists at the moment.
Amazing. Thanks so much, Anna. Seems like that was useful for John. Yeah, keep the Kubernetes questions coming. Also other questions as well. Also, gateway you say. Soon there will be many, many gateways. Also keen to since we have a little bit of time to discuss uh charts as well. I know that that's something that we wanted to kind of cover last week. So yeah, don't want to put the GraphOps team on the spot, but if you guys want to say anything about charts, feel free to. Or if Pinax team, if you want to hop into this as well, feel free to as well. Oh yes, and don't forget the Poe app there. Thank you for sharing, Pili. It's a very important part of today's call, of course, to get the Poe app. There you go. Awesome. Yeah, keep the questions coming too as well. See a few people typing. Let's see what comes of it. Yes, Matthew, more everything. That's always good. Growth is good. Amazing. Thanks so much for sharing, Chris. As you can see there, folks, there are a bunch of links for officially supported charts in Launchpad, GraphNode, and GraphNode Network Indexer as well. Amazing. Let's keep the questions coming. We've got another 6 minutes or so, so if folks want to fire away, feel free to. We've got the Pinex folks who are pretty competent when it comes to Kubernetes, so yeah, fire away. +1 for GitOps, by the way. Git really does the whole version control part well. Nice. Good to hear. Good stuff. Kubernetes Mafia, yes. Yeah, definitely building a lot of expertise in Kubernetes. It still seems like people are like hesitant with Kubernetes. I wonder, not to put you on the spot, Steak Machine, if you're still here. Is Steak Machine still here? No, he's not. Is he? No, he's
The
not.
whole thing
Okay.
to get used to. That's why, I
Yeah.
will put myself in the hesitant to join Kubernetes camp. Well, originally. It's yeah. Right? If you're used to doing things a certain way, learning a whole new stack is a whole lot of work. So
Yeah.
yes, the Borg. So I totally understand everybody who's in that frame of mind.
Indeed. Yeah, but it's very important for scaling your operation. I guess maybe are people feeling the pain of not using Kubernetes? Because that's I guess what would drive you to want to uh, learn, because as you say, it's a friction, right, to learn a new stack. And I guess the only way to overcome that is to have a strong need for it. Like yeah, I'm very
I
curious.
think it depends how big you want to scale your infrastructure. Right? So if you want to be an indexer and you want to focus on, I want to be the best Ethereum indexer, and I want to just focus on that chain, then you don't need so much infrastructure. I mean, you need a lot of Postgres nodes. You need to scale your graph node. But, can you do it without Kubernetes? Probably. Well, for sure you can. Right? So, and it probably was not painful. But, if you're trying to run all the chains on multiple data services and blah, 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 well, then that's a whole different scale of problem. So I think, looking at this, you need to start with your own goals and objectives. But, we can also see that there are small indexers who are embracing Kubernetes as well. So it's not an all or nothing thing.
Yeah, definitely. I totally agree, and it's definitely geared towards people who have the goal of scaling up their operations. I wonder, Steak Machine seems to have come back, which is great. Yeah, as I said earlier, not to put you on the spot, but I'm very curious if anything has changed about your perspective on Kubernetes after today's conversation. Your general kind of thoughts, because I remember at the top of the conversation you weren't so keen. So I think it'd be really interesting to hear your perspective, if you've got one, either in chat or on mic, whatever you prefer.
What's interesting is now we're at Pinax in the state of, we have stuff in Kubernetes and we have stuff not in Kubernetes. And now we need to bridge the Kubernetes stuff with the non-Kubernetes stuff. So that's a whole new thing that we're looking at as well. How do we make the transition from old style to new style without, downtime?
Yeah, of course. Actually, while Steak Machine's in the group, maybe you can share a bit about that, and tell us a bit about how that experience is going. Maybe there's some alpha that you can share with the rest of the crew that could help them.
Yeah, I'm not sure I have any alpha to share, other than, or maybe Guillaume can. So all of our stuff originally was deployed in LXC containers. So if you're using, different tools, they might use LXC containers or KVM or whatever. And yeah, so we started with everything in LXC. Most things are still in LXC, actually, like Proxmox. Yeah, those LXC containers fine. And now we're, deploying Kubernetes cluster. We're thinking about putting the control plane nodes maybe in Proxmox, so we can still keep there. Vince, Talos is the answer for everything. Guillaume, what were you looking at in terms of bridging the LXC containers to the Kubernetes? You were looking at something last week.
Well, I'm gonna break the scoop now because it works as of yesterday. So now you know. But yeah, what we're doing right now is basically we have our own DNS provider inside of Kubernetes, and we use Crossplane to be able to provision and monitor some external endpoints outside of the cluster. So basically, because we have a bunch of applications running in LXCs that are outside of Kubernetes, but we want to use the the infrastructure DNS provider inside of Kubernetes for those services. So this way we can keep those services, but migrate them to the cluster at some point or not. Really, we want to have the freedom to choose what we do. So we're using Crossplane to create services and really they're headless services with endpoints to stuff that's running outside of the cluster, but still being able to reconcile from GitOps and from inside of the cluster itself, the services that are running outside. So yeah, we're using Crossplane for that. Yeah, 𝗨𝗀𝗲𝗂𝗧 is also really interesting. I've played with it a fair bit to set up Kubernetes cluster, and it's pretty great. It's pretty great. If you have some VMs that you want to manage in Kubernetes, you can use 𝗨𝗀𝗲𝗂𝗧 obviously to sort of scale, upgrade, and manage your VMs as Kubernetes pods.
Alrighty, folks. Any final questions, thoughts that people want to share? Maybe another shout out for Talos from Vince.
Sounds like we're going to get a Talos office hours on November 5th.
Yeah. I think that's probably what's going to happen. Yeah, we've got Vince coming on the 5th of November, so rest assured. Oh wow, that's a great gift. That's a great gift. There you go. There you go. Well, look forward to that, folks. It's going to be a great conversation. Vince is always fun to hang out with, so I'm looking forward to that one. You had to. Oh yeah, definitely. That came way too quickly, Vince. Like that was in the ammunition before that got fired off. I know. That's a good one. Alrighty, folks. We're at the top of the hour. If anyone has any burning questions, of course, please interrupt me. But if not, then I'll take this opportunity to say a massive, massive thank you to Guillaume and Matthew for presenting today, and of course, everyone else for joining as well. We'll be back again same time next week, 6 p.m. UTC, and we'll be having the Blast team. So we are, if you guys remember, whenever we support a new chain, we generally have the team come on, tell us a bit about their chain, how to run nodes, any tools, tips, etc., etc. So I'm coordinating with the Blast team so we can get that sorted for next week. So look forward to that. Hopefully see you guys there. Again, big shout out to Guillaume and Matthew and the rest of you for joining today's conversation. And yeah, we'll see you again next week. Take care, everyone. Bye-bye.